In question number 4, we were asked to find a set of parametric equations for the line that contains these 2 points. So for parametric equations, we need 2 things. We need a point on the line, and we also need direction numbers that we would get from a parallel vector. So let's call this point P and this point Q. So the vector PQ would have components 5, 3, -4. And this is going to be parallel. This vector is going to be parallel to the line that we're looking for. So for the parametric equations, we take either point, either the P or the Q. They'll both be fine. And now we have our direction numbers, 5, 3, and -4. Those are the coefficients of the parameter. So we'll have 5t plus 3t and minus 4t. Other answers are possible. In question number 5, we are asked to find an equation for the plane that contains these 3 points. So what we're going to do is the following. We're going to find 3 vectors from these 3 points. I'm sorry, we're going to find 2 vectors from these 3 points. And we can find any 2 we like, as long as we don't do something like this. We don't want to find PQ and then QP. That's not going to be good enough. We want 2 vectors that are not parallel. So I think I'll find PQ and PR. Alright, so the vector PQ would be -2, -7, 5. And the vector PR would have components 3, -4, 1. Alright, so now that we have these 2 vectors, what we're going to do is find the normal vector to this plane. So the vectors PQ and PR both lie in this plane. We need a vector that is perpendicular or orthogonal to each of these 2 vectors, and we find that by using the cross product. Right, the cross product will be orthogonal to each of the original vectors. Alright, so I've set up the determinant. So the coefficient of I is going to be this 2 by 2 determinant. And that should be -7 minus -20, which would be -7 plus 20. The coefficient of J should be that 2 by 2 determinant, which would be -2 minus 15. And then the coefficient of K would be that 2 by 2 determinant, which would be 8 minus -21, which would be 8 plus 21. So the vector would have components 13, 17 and 29. Well, we've done the hard part. Now all we have to do is put together the equation of the plane. And so we're going to take the components of the normal vector. The 13 we're going to multiply by x minus the x-coordinate of any of these 3 points. It doesn't matter which one we pick, as long as we use the same point for all 3 parts. So I'm going to go with the first one. So I'll have x minus 2. Then we'll have the y component here would be 17, and that'll be times y minus the y coordinate here. And then we have the z component here, that would be 29, times z minus that z coordinate. Z minus a negative 1 would be z plus 1, and that's going to be equal to 0. In this last question, we're asked to find a set of parametric equations for the line of intersection of these 2 planes. So you might remember that what we do is first find the coordinates of some point that lies on the line. And so what we typically do is set one of the variables equal to 0 and see what the other points have to be in order to match that. So I'm going to set x equal to 0. And if I set x equal to 0, that's going to give me 4y plus 3z equals 5, and negative y plus z equals 0. And so here's a system of equations in x and y and z, and we need to solve that for y and z. Well, this bottom one tells us that z equals y. That's nice. So if z and y are equal, this tells us that 4y plus 3y equals 5. So 7y equals 5, or y equals 5 over 7. And then we also know that z is equal to 5 over 7. And of course, x is equal to 0. Now you could have done some, you could have set y equal to 0, you could have set z equal to 0, any of those would work, I believe, and you can get the 3 points that way. Now what we need to do is find the normal vectors here. Those normal vectors will each be orthogonal to the line of intersection. So what we're going to do is find a vector parallel to this line of intersection. Well, that vector has to be perpendicular to this plane's normal line and this plane's normal line. So what we're looking for is a vector that is perpendicular to 2 other vectors. That sounds like the cross product to me. I'm being attacked by a tomcat. Or at least my pen is. So we've already talked about how to find the components of the normal vectors. We get those from the coefficients of x, y, and z. Alright, so this cross product should be I times 1 minus 6, and then minus j. I'm sorry, I did that wrong. It would be I times 4 minus a negative 3. That's 4 plus 3. minus j times the determinant here, so it would be 1 minus 6. And then k would have as its coefficient the determinant -1 minus 8. So that's going to be 7, 5, and 9. Actually, it'd be -9, wouldn't it? So now we've got points. We've got a point, and we've got direction numbers. So we want to come up with parametric equations for the line that passes through this point and is parallel to this vector. So that would be, for instance, zero plus 7t, 5/7 plus 5t, and 5/7 minus 9t.